This ain't Utopia Planitia, believable starship designs. Media properties like Star Trek or Star Wars tell us that space travel is easy and that starships are act like boats or planes. This is a terrible, terrible lie. There is a lot more to spaceflight than common media depictions show, and there's a lot of mileage you can get by knowing some of the principles behind realistic spacecraft design. This discussion was held at the Ad Astra Science Fiction Convention in 2016.
Thank you for coming this early to This Ain't Utopia Planitia, Believable Starship Designs. I think that was the last bit of it. And I would know because I was the one who suggested this panel and named it.
Therefore you should be moderating.
But yes, so this is about things to consider and things to not consider if you're a writer. If you're a writer that's designing a starship for you or whatever, or if you're a reader who just wants to know more about what goes into these things. So let me get the panelists to introduce themselves.
Okay. I'm Stephen Pearl. I have no idea why I'm on this because I've not done any space-based science fiction.
Okay,
that's currently published in any case. I'm trying to sell a couple, but I got some thoughts.
But in that case, why don't you be moderator?
You can keep the hot potato.
Good morning. Thanks to everyone for coming out bright and early on a Sunday of a con. I'm Eric Choi. My background is actually in aerospace engineering, although at least officially I've never built a starship or designed one. I have worked on Mars missions and the Canadarm2 on the International Space Station, a bunch of satellite projects, and I'd be interested to apply some of that to fictional starship design. I'm also a writer and editor. Most recently, I have a story in the April Analog, and just sold it out on 2 Analog papers.
Thank you. I'm Cameron S. Currie. I'm a science fiction and fantasy author. I have designed a lot of spaceship stuff, although surprisingly a lot of it doesn't come out in the books. Just I guess I'm a bit obsessive about detail for some reason. But anyway, yeah, so that's why I'm here, I guess.
And I'm Andrew Barton. I'm a science fiction author. I write mostly in analog, actually. And I have designed multiple starships with a 20-year-old calculator, but they're just columns of numbers.
Okay, so
to be perfectly honest, I didn't expect to be moderating this panel, so I don't actually have any questions.
Okay, I'll start off with a thought that I've had. In any discussion of starship design, there's a couple of things you have to go in defining. First of all, what is your tech level? And you have to have a clear idea of what your tech level is because that's going to affect everything that you do. The other thing is, how in the box are you going to be? Because if you start thinking in sort of sidereal ways, you can have starship designs that are completely organic. You know, you make a plant-animal hybrid so that the waste of one feeds the next one. You put in a genetic splice so that it can feed on asteroids and get its initial oxygen and metals by actually devouring asteroids and grow to whatever size you need. Then it becomes a closed circuit system that basically can go for years between suns. But it eventually has to recharge because no system is absolutely closed.
It could propel itself through space by farts or something.
Yes, yeah.
yeah, I think one of the most important things too, kind of in a similar vein to what you were saying, is that obviously in the realm of science fiction, you've got to decide: are you working with an extension of modern day technology, slower than light travel, that sort of thing, or are you talking about warp speed and stuff like that? Because obviously they're two entirely different concepts, I guess.
Yeah, and also, what are the limitations on your warp speed? Because let's say, okay, I have one postulate I have in the one I'm trying to get published right now, is that the only FTL system is a form of transfer gate with basically anchored wormholes. And any ship has to be built to the specifications that will fit through that gate, if you want. So, okay.
Many, many moons ago, Michael Kuda and Rick Sternbach wrote a nifty book called the Star Trek TNG Technical Guide. And Gene Roddenberry wrote the introduction to that book, and he made an interesting point, and he said that the Starship Enterprise is a real vehicle. Not a real space vehicle, but a vehicle for storytelling. And I think that's something important to keep in mind, that I could, people like me or Andrew or Stephen or anybody can pontificate about, oh, well, this isn't realistic, this is the way it really works. But at the end of the day, particularly for visual media like television and movies, sometimes practicality gives way to just plain coolness. And, I, for one, don't really have a big problem with that. Although sometimes it is kind of interesting to think about, well, if we were trying to do this for real, what would it really look like?
I think that to an extent I agree with you. I understand why they have big rooms on starships, which is ludicrous. Because I think the best current technological model for what the internal structure of a starship would be like would be a submarine. Both designed to go through hostile environments, both expensive and difficult to get where they're going. But I understand big rooms. But with the J.J. Abrams sets in the new Star Trek reboots, I'm sorry, I can't get past it to enjoy the movie. Getting sucked through these huge pipes for the water reclamation system.
That's the next panel.
Yeah.
It's two panels from now, Technobabble at noon.
Yeah, I'm on that one too. But there's a balance to be had of the duty of the story, the functionality for storytelling versus being at least a little bit giving a nod to what the reality.
Well, if we're going to we're going to kick on Star Trek now, then I'll continue. I'll continue that thread.
Well, that is appropriate because
it's Utopia Planitia.
Okay.
Obviously, I love Star Trek. I love it to death. But one of the very interesting things, if we look at the various incarnations of Star Trek, is that they measure technological progress, and forgive me if this sounds rude, by size. So going from the Enterprise NX-01 to the Enterprise E of whatever letter of the alphabet they haven't put down yet, these ships are getting bigger and bigger and bigger with larger and larger crews. And as Stephen has pointed out, in the real world, in the real space program, it's actually the opposite. That with automation, we need actually fewer people to operate we need fewer people to operate an airplane. I mean, there were times in the early jet age, in the 60s and the 40s, the late 50s and 60s, where there'd be typically 3 or 4 people, operating a commercial airliner, and now we're down to 2, even though.
And even the second one's kind of a redundancy.
Sorry.
I would say the second pilot in an aircraft is in terms of flight technology and stuff, is technically a redundancy, but in reality, there are very good reasons to have.
Oh, in case the other guy goes crazy.
Well, that's what I meant, redundancy in a useful sense. Sorry, yes.
I agree with the idea of these large rooms, large starships. Seems a bit ludicrous the way we're going to reduce things. On the other hand, perhaps they shouldn't be quite so large. You do have to consider, supposedly, they're on very long missions.
Isolated missions.
I think a few bodies around to save people going nuts psychologically, and maybe to sort of clear the mice up or the rubbish if somebody gets knocked out or blown up or something.
There is actually another
so
reason
you need
for
a bit
size
in between, I think.
that I'll mention, but let's take that gentleman's question.
One thing also that Star Trek did I talked about going back to the original series in the 60s, a lot of people tended to view spaceships and starships being streamlined, things like that. But that doesn't make as much sense in space as people realize. Star Trek broke that mold. And that was
It
one of
did,
the few salutary things it did.
Yeah. Although that does go a little bit back to what your tech level is
Yeah.
and the parameters that you're setting. Like I said, in this one book that I've written, they have to fit through the stationary wormhole.
Yes.
So it has to be configured to do that. But another, oh shoot, I lost my chain. I'm sorry.
I'll get another question from the panelists because it also relates to this visual aid that I brought. This is, if you may never heard of it, this is a model of Skylon C1, which is under development by Reaction Engines Limited in the UK. This is a single-stage orbital space plane that's supposed to take off a regular runway into orbit and come back. It's about the size of a 747, and these engines mean that while it's in the atmosphere, it can fly like a jet, essentially. But even with that, this is the payload, and everything else is the storage for the reaction mass to get it that last way to orbit. Just to underscore, because starships do need to be big to store all of the reaction mass they need if you are writing a starship that is halfway realistic. So I guess, what would you say about understanding the rules under which a spaceship works before breaking them?
Yeah, I think it goes back to what Stephen said earlier, is what level of tech you are assuming. So if I go to what I'm familiar with, which is the world of Newton and the world that is about us nowadays, and the world of engineering that I've dealt with, then Andrew is absolutely correct that size, if you will, does matter, but not necessarily in the way you think. It's things like propulsion, because you're not in a working medium. Propulsion is everything, or what they call delta V, change of velocity, as well as micrometeoroid and radiation protection as well.
Yeah.
Was there a question at the back?
Yeah, there's a bit of a problem with the discussion that you're having here. You keep talking about tech levels and size, but you're not talking about what's the purpose of the Starship. How you design an exploration ship would be different from how you design a colony ship, would be different from how you design a warship.
Yes.
As well, I do want to make the point also, there's huge differences between a launch vehicle and a ship that's actually just designed to stay up there and maybe be a platform for landing and launch vehicles.
Well, I think it's like the name of the panel there, where it's talking about starships. It's star-to-star type vehicles as opposed to
Not necessarily, because that wasn't my intention when I
okay.
wrote it. So.
Fair enough.
Things
Then
that
tell
go
us
in-
what to do.
Things that go into and through space.
Okay, fair enough.
Okay. But also, if you're looking at near future, let's say next 100 years, you're probably going to have a hell of a lot of mass going up, because ultimately, right now, the only effective shielding I've heard about against a lot of the radiation is to have basically a big tank of water around you to intercept the particles. So you're looking at bringing a huge mass of water, whether you get it from the moon, from Earth, from Mars, the asteroid belt, you still have this mass that's going to have to go there.
Yeah, so that type of mass is what you would need to protect against, say, gamma radiation. There have been proposals, basically you can think of as a sort of primitive deflector shields, is basically generating artificial magnetic fields around ships that would trap or deflect charged particles like protons and electrons, which is like the mini magnetic field of the Earth.
Now, is there a bit of a problem for us that when you shut them off, suddenly everything collapses?
No. One problem at a time.
Good question.
Could you give us an example in popular media where they design spaceships, almost true to life or true to life versus?
I would say the series The Expanse is the most scientifically accurate example of this concept I have ever seen on a screen. The Expanse is the series made out of the books by James S.A. Currie.
Leviathan Waste.
Yes. And yeah, the first scene, the very first episode has the character ship responding to a distress call while it's on, like it's an ice miner going from Saturn to Ceres. And in order to make it basically, you see, it's the first time I've ever seen this on television. The craft like flips over and does a deceleration burn.
That was done before, actually, on Babylon 5.
I was going to say, I was actually going to say Babylon 5 as being a fairly decent one for a number of different reasons. I liked the notion that every race clearly had a different level of tech and a different design, a very distinctive design, from the Minbari, where they were almost fish-like and very organic, which you talked about earlier, Stephen, versus the very utilitarian gray and metallic Earth technology. And that some people had artificial gravity and some people didn't. Unlike Star Trek, where everybody's ships look different, but the base
They're essentially
technology
the same,
is kind of interesting. I also like the design of the Star Fury fighters on Babylon 5 because they actually got. So somebody actually gave it some thought that if you contrast it to an X-wing fighter from Star Wars, the X-wings had the propulsion system inboard and the weapons outboard, and the Star Furies had it the other way around. They had the guns near the bore site and the engines on the outside, which makes perfect sense because you have a longer moment arm. You can do attitude control much more effectively, and then you have the weapons in the bore site that conceivably improves your targeting. So I found that quite interesting.
Going into that, to making Babylon 5, Straczynski actually spoke to NASA scientists and said, how do things move in space? Because he wanted to do the most realistic movement of the ships that he could. And that was one of his raison d'etres for the show.
So we have a question there, and then
Got one over there as well.
What are your guys' thoughts on some of the more esoteric things that are near future, like Project Orion? Like dumping nukes out the butt?
I would say that
It was all oh, sorry, I just spoiled something.
I would say that there's nothing near future about Project Orion in terms of technology because it is something that we could have done 50 years ago if we had wanted to.
Maybe, sorry, for people who don't understand, maybe just summarize
Yes,
what that
okay.
was.
So Project Orion is an idea for a spacecraft which could not possibly go wrong in any idea, any way.
No problem.
Yes, because it is, you have a ship, your payload, and below it you have a number of delivery tubes and a very strong blast shield, which you need because the Orion drive ship moves by detonating nuclear weapons behind its shield, and it ejects a small nuke out the back, and it goes off. The force of the explosion pushes it forward.
This is how we beat the aliens in Footfall, if you ever read that.
Yes.
What I think is likely to be in the next few centuries, one to maybe 3 centuries, is a hybrid ship that will utilize a combination of solar sails and ion drives. Sort of like the stage of technology that we went through in the 1800s, where they had primitive steam engines, but they weren't very efficient, and they coupled them with sails on many vessels. And you had this hybrid, and the steam was only used when you didn't have the wind.
Or the galleys before that, oars and the sails as well.
Yeah.
Oh, yeah,
you
actually too much.
Just in terms of help, learning how things move in space, there are resources out there, including games such as
Kerbal Space Program.
Okay. That right there gives you a simplistic but pretty accurate view of how things maneuver in space. And there are mods available, including the Orion Drive.
I will agree with you and acknowledge that Kerbal Space Program is responsible for about 99% of my orbital mechanics knowledge.
Was that back there?
Yeah. Yeah.
Just for history of Project Orion, Freeman Dyson son was involved in the work of Project Orion in the 60s. He wrote an excellent book about the history of the whole project. Actually, he did a lot of all the theoretical work in the 60s and actually flew a small chemical fuel test model. They proved the basic concept for the project. He never got it. It was an excellent history of the North test.
Now, what I find very interesting is, as Stephen has pointed out, we're actually realistic. There are serious people contemplating starflight now. Obviously not with people, but at least with an on-weight probe. Most recently, Yuri Milner's announcement of the idea of doing a laser pump light sail to accelerate a very small spacecraft with very simple instrumentation out to a nearby source.
I was actually just going to bring that up because I want to see what do the panelists think about, well, not necessarily, well, maybe the believability, or even in terms of fiction, like say this was something you encountered in the work of fiction. Do you think it's believable to want to send a probe like this? Because sure, theoretically, we could build a laser system to launch a light sail probe to Alpha Centauri in 20 years, but this would be, by the plans, a probe the size of a computer chip. And does it really make sense to invest all of this development in a probe only capable of taking really crappy photos?
Well, I think number one, this is the cool factor, of course.
Yeah.
But,
Always that.
number one, I think that we, with the space program, put the cart in front of the horse. The first thing we need to do is get a launch system that isn't throwing rocks. And that's effectively what our current launch systems are. We put a little payload on a big pile of explosives and set it off. Now we direct the thrust in one direction, but really that's effectively our launch systems. So we really need, for a start, to make an effective launch system, whether it is a magnetic catapult or a space elevator, but something that can get payloads up there of reasonable mass without this huge, huge, huge expenditure of fuel and expense.
Especially before we run out of fossil fuels.
Right. Admittedly, most of the time they're using hydrogen oxygen. So.
Well, okay, fair enough. But yeah, it's actually there was the crap. What was it? The
Falcon 9?
no. There was that contest. Well, you got to know what this is. The contest. X Prize. Thank you. The X Prize. Yeah. There was a couple of people that were doing stuff. There was the Da Vinci project where they raised the launch vehicle to a certain level with balloons, and then launched it from there. Because as I am, you can obviously contradict me if I'm wrong, but where the escape velocity is lower launching from a higher altitude. Is that?
That's gravitation to overcome.
Yeah.
Well, you're basically getting above the thickest part of the atmosphere,
Yeah.
which is where most of your thrust is expended. But
Yeah.
both of you raised excellent points that sort of on a sort of technological canvas writ large, we really don't have a lot of the basic tools to enable a lot of these ambitions, at least not just yet. And I think of the Antarctic analogy. So there are a number of bases, scientific bases in Antarctica that a number of countries have put down there. And it is a huge logistical operation to resupply, to crew and to resupply these stations. There's a certain window of a season that you can fly planes in and out, like a big C-17 or something to put down in McMurdo or something. So it's a huge challenge to do this on Earth. And people have tried to do the analogy as well. We could have bases, say, on the moon, analogous to Antarctic bases. And yet the whole Antarctic bases are supported by a whole technological industrial infrastructure of being able to operate things like airplanes and all-terrain vehicles that we simply don't have yet for space.
Any meaningful advancement is going to rely on decent launch system and basically closed systems up there that
Because
are
we're going to be
basically
building these
self-sustaining.
spacecraft up there.
Yeah.
You know, you don't want to launch something off like Orion off the surface of the Earth.
Of
Maybe
course-
if it's a part of Earth you don't really ever want to use.
All right, I'm not going there.
Where they launch star bombs.